Welcome to EDU World Space.
In this question, cars A and B are traveling in a circular track. So car A is moving at 90 feet per second to the left, speeding up at 15 feet per second square. Car B is moving at 105 feet per second, but slowing down at a rate of 25 feet per second square. And then we want to find the velocity and acceleration of A relative to B. Okay, so this is a relative motion problem. So as a start, we always need to write down the velocities and accelerations in vector form so that we can calculate the relative velocity and acceleration easily. Okay, so first we start with velocity. Okay, VA is negative 90 I hat feet per second, and then VB is 105 times minus cosine 60 degrees I hat plus sine 60 degrees J hat feet per second. So velocity of A relative to B is defined to be velocity of A minus velocity of B. Okay, so you put the components together. Okay, then you calculate the values of each component. You get negative 37.5 I hat minus 90.9 J hat feet per second. Okay, then from here you can calculate the magnitude of the relative velocity. So it's equal to 37.5 square plus 90.9 square root, and then calculate this, you get 98.4 feet per second. And then the direction for this will be tangent 90.9 divided by 37.5 is equal to 67.6 degrees. Okay, so this is how the direction look like. Okay, so this is our velocity of A relative to B, and then this is 67.6 degrees. Okay, so just to box up the magnitude of the relative velocity and the direction of the relative velocity. Okay, next we look at acceleration. So the acceleration of A is equal to negative 15 I hat negative minus 90 square divided by 300 J hat. So this is the tangential component. This is the normal component. Okay, for car A is pointing downward. Okay, so if you calculate this, you get negative 15 I hat minus 27 J hat. Okay, feet per second square, and then for car B, okay, for car B, just look at this diagram. So the car B is slowing down at 25 feet per second square. Okay, so it's pointing in this direction, and then the angle is 60 degrees. Then so this is our AB sub t. Then we also have the normal component. Okay, this is 30 degrees. Okay, and then the magnitude of the normal components for car B is 105 square divided by 250. Okay, yeah, so it's V square VB square divided by RB. Okay. So based on the diagram, we can write down the acceleration of car B in vector form, which is 25 cosine 60 degrees minus 105 squared divided by 250 cosine 30 degrees. This is the I hat, and then we have the J hat, 20 minus 25 sine 60 degrees plus 105 squared divided by 250 sine 30 degrees J hat. Calculate the numbers, you get negative 25.7 I hat, negative 43.7 J hat. Okay. So we can calculate the relative acceleration. So relative acceleration of A respect to B, okay, is equal to acceleration of A minus acceleration of B. Okay, so you have minus 15 plus 25.7 I hat minus or plus minus 27, negative 27 plus 43.7 J hat, and you get 10.7 I hat plus 16.7 J hat feet per second square. So the magnitude of the relative acceleration, sum the components, sum of the square of the components, and you take the square root, and you get 19.8 feet per second square, and then the angle is the arctangent of the y component divided by the x component. Okay, you get 57.4 degrees. Okay, so visualizing the direction of the relative acceleration is pointing in this way. Okay, so this angle is 57.4 degrees. This is the relative acceleration of A respect to B. And then this is the magnitude. Okay, just to box up the answers and the direction. Okay. And that's all for this question.